Boom! Alright folks, Hume again. So if you have been following the videos on trigonometry, you would have realized that in the last video we would have done the 30, 60, 90 triangle. Alright, now in the series of recordings which I did, I went ahead to the next triangle without doing the part that we have to do now. So what I'm going to do here is record a video now on the 60 degrees which I had omitted before, slip it in, and in the next video we will deal with the 45, 45, 90 triangle. So this is, you could call it a continuation, you could call it a sequence, you could call it part 2 if you want, of the last video where we did the 30 degrees. In this video we're going to do the 60 degrees. Again, just to drive the point home. Alright, so with the markers and that. Right, so we have here, again, just by way of remembering, 30, 60, 90, this is the 1, 2, sorry, let me start with the actual numbers. This is 30, 60, 90. They actually call it that, which if you break it down as a ratio, it will be 1, 2, 3. So you could call it a 30, 60, 90 triangle, you could call it a 1, 2, 3 triangle. Again, just for the sake of remembering, this is the ratio of the angles, not the ratio of the length of the sides. So if we make 60 degrees the reference angle as opposed to 30 in the last video, then you would see that the sides that comprise the ratios would change. Now notice what I did here. This is the exact triangle as this. This is what we refer to as equivalent triangles. Alright? How do I know it is the same triangle? Because I use the same set square to draw the both of them. Alright, I would have changed the orientation here just to drive home the point to people that now getting into this topic, to people that have a little, one or two little issues with it, that you wouldn't always expect the triangle to look a particular way. So what you don't want to do is go in expecting the reference angle always to be on the base here on the left side. It could be on the base here on the right side. The reference angle could be up here as well, right? The triangle could be oriented anyway. The most important thing you have to look for is the little box in the corner that says that the triangle is a right angle triangle, or some other piece of information that will tell you that you're dealing with a right angle triangle. And once you know the triangle is right angle, then you could do everything else where the trigonometric ratios are concerned. So going back to this triangle, and we have the corners labeled the same way here as they are over here. So if we make 60 the reference angle, then this being the hypotenuse, of course, the hypotenuse is always the hypotenuse. Then with 60 as the reference angle, this will be opposite, this will be adjacent, and that will be hypotenuse. If you want to label it over here, 60 degrees, opposite, adjacent, hypotenuse. And with that convention, you will now have that the sine of 60 degrees is equal to opposite over hypotenuse, which in this case, the opposite is AB, same AB across here, AB over hypotenuse AC. You'll have the cosine of 60 will be the adjacent over the hypotenuse, adjacent over the hypotenuse. In both triangles, it would be BC over AC, BC over AC. Adjacent over, hold on, hypotenuse. Alright, which is BC over AC. And then you have the tangent of 60, which is equal to opposite over adjacent, opposite over adjacent, AB over BC, AB over BC. Alright. Sorry, I write the wrong thing here. This is supposed to be opposite over adjacent, AB over BC. And that's the three ratios that you want to use. So these are the ratios. So if you compare this triangle to the one in the previous video, all right, for both 30 and 60, the size that they use for the ratios are the same. Sorry, the size in terms of the labeling, whether it's opposite, adjacent, or hypotenuse. However, the actual side in terms of the triangle itself would be different based on where the reference angle stands. And just to go back to where we started, I'm going to take this triangle out of the picture now and go back to the beginning with the 30, just to make a small point here. So back to the 30. We know that the sine of 30 is equal to what? Opposite over adjacent, right? With these 30 degrees, I'm going to rub this off now just for emphasis. This will be opposite, this will be adjacent, and this will be hypotenuse. So sine 30 opposite over hypotenuse, alright, it will be CB over AC. Sine 30 will be opposite over hypotenuse, it will be CB over AC. The cosine of 30 will be equal to adjacent over hypotenuse, K, AB over AC. Adjacent over hypotenuse, which is equal to AB over AC, and the tangent of 30 would be equal to the tangent of 30 will be what? Opposite over adjacent, BC over AB. Opposite over adjacent, which is equal to BC over AB. Now, why am I doing this? I'm doing this to make a point. The point I'm going to make is that if you look at these 6 ratios that we have here, you would see that the sine of 60 is AB over AC, and the cosine of 30 is also AB over AC. You look at the cosine of 60. The cosine of 60 is BC over AC. The sine of 30 is the same. Well, I have it as CB. It's supposed to be BC, right? Remember, we stick into the anti-clockwise. So that we fix that here. You'll get the same BC over AC. So the cosine of 60 is BC over AC. The sine of 30 is BC over AC. Yeah? And if you look at the tan now, the tangent of 60 is AB over BC, and the tan of 30 is BC over AB. So let me look at the sines and the cosines first, just to drive home a particular point. So looking at this triangle, we see, therefore, that the sine of 30 is equal to the cosine of 60. And we also would have seen that the cosine, well, it's the same thing really. Well, no. Let me write it over the next way. We will also see that the sine of 60 is equal to the cosine of 30. Right? Sine 60, cosine 30, sine 30, cosine 60. And in fact, in general, we know that the sine of theta is equal to the cosine of phi. All right? This is as simply as I'm going to put it for the benefits of the people who do in mathematics. The people who do in admaths would know that relationship in a slightly more complicated form, but we're going to leave that out of this video. Remembering, of course, that the foundation of this is this. So this only happens if the triangle is a right angle triangle, which by definition means that the other 2 angles must add up to 90 degrees, and once that is satisfied, then the sine of one angle is equal to the cosine of the other angle, and the cosine of one angle is the sine of the other angle. That's basically it then. Right? So I can say sine theta is equal to cosine phi. I could also say that let me see how much space I need here. Yeah, I could take this out now. I could also say, for the sake of argument, that the sine of phi is equal to the cosine of theta. I could say that too. So these are 2 lines that pretty much mean the same thing. Part 1, and part 2. Alright? Now, would you be called upon to make regular use of this in the course of a regular maths exam? Maybe, maybe not. But on the odd chance that you see a question where you're called upon to use this relationship, they might actually give you the relationship or they may not give you the relationship. Generally speaking, if a particular relationship is not a regular part of the syllabus, they will give you the relationship. So if we could use the CSEC syllabus in the Caribbean as an example, if you ever to get a problem where you have to use this relationship, chances are that they will tell you that the sine of theta is equal to the cosine of phi, or they might give you some kind of question where you have to derive the relationship between the sine of one angle and the cosine of the other angle. That is a question they could get too. Good. So if that is the case and you would have seen this video, then it would trigger something in your memory in an exam situation. And that is why sometimes in the videos I would go the extra step of mentioning 1 or 2 things that may not necessarily form part of the regular syllabus, but by simple virtue of having seen it in the video, if you get a question like that, it will jog your memory. And you'll say, but wait, Hume had covered that in one of his videos some time ago. And that little nanosecond of connection there, that will make all the difference in solving the problem. In you remembering that, A, sine theta is equal to cosine of phi. Blang, 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 blang. Right? They might use different symbols to represent the angles in the question. But having gone through this, you make that connection and you can solve the problem, right? Because a lot of the exam boards now, they bring in trickier questions and trickier questions. Because let us face it, the information to prepare is so much more readily available now than it would have been before, right? When I was doing A-levels, I would have had to write a letter to Cambridge to get the past papers and the reports. And then they'll tell you how much it costs, and then you have to go in the bank and do a wire transfer, and then you wait about 2 or 3 weeks, and then you go in the post office and collect this big package of past papers and past paper reports and solutions and things, right? That is what it would have been back in the late 90s when I did A-levels. Now you go online and everything there, past paper solutions, reports, YouTube videos, this, that, blah, blah, blah. So there is no shortage of information now. So you find that the examiners making the questions a little more trickier, giving people a little more headache then, so to speak. So you have to think a little bit. So as I go through the topic, I would mention 1 or 2 little things. And that is why it is so important to look at the videos in their entirety, because if you do like what some people will do, and alright, after you watch the first, let me say the video is 13 minutes, after 6 minutes you're bored and you're fed up, right, and you switch out, and these little golden nuggets come in the pad that you miss out, and then you go in the exam and you don't have that background. Alright, so if you're still here if you're still here in this video, then I want to encourage you to keep that up. I want to encourage you to encourage other people as they watch as you spread the word and you tell them about the videos now. Make sure and encourage them to watch the whole thing, because it always have something in there. One little thing that could make all the difference in the world in an exam situation or otherwise. Good. So that is it for now. I'm gonna I'll cut the video now and just make one brief addendum to this using the actual values, and then after that the next video will be the 45, 45, 90, and that's it. And after that it will just be one example, and that's it for trigonometry. Everything else you'll have to come on the online platform to get. Yeah, so stay in the game, keep in tune, plenty more coming your way.